Good morning, children. Today we are going to explain the structure of glucose. Glucose is correctly named as D plus glucose. D plus glucose, where D represents the configuration and plus represents dextro-rotatory nature of the molecule. Dextro-rotatory nature of the molecule. Rotatory nature of the molecule. The letters D and L. D and L. Before the name of any compound indicate the relative configuration of a particular isomer of glyceraldehyde. Glyceraldehyde contains one asymmetric carbon atom and exists in two enantiomeric forms as it is shown here. CHO, OH, H, CH2, OH. And the other form is isomer is CHO, OH, H and CH2, OH. The most oxidized carbon is at the top, and the name of this one is plus glyceraldehyde, and here is your minus glyceraldehyde. The most oxidized form of carbon is at the top, the aldehyde group. And look at that. When we go for the most oxidized form to the next senior group, that is then hydrogen and OH. Of these two, which one is superior? OH. So the rotation is clockwise. Whereas in this case, the rotation is anti-clockwise. So that's why for clockwise here is your plus, and for anti-clockwise it is your minus. So there are two isomeric forms of glyceraldehyde, that is plus glyceraldehyde and minus glyceraldehyde. All those compounds which can be chemically correlated to plus isomer of glyceraldehyde, that is your this one, are said to have D configuration, whereas those which can be correlated with negative isomer of glyceraldehyde are said to have L configuration. When it is correlated with plus glyceraldehyde, then the configuration is D configuration, and when it is correlated to minus glyceraldehyde, then the configuration is L configuration. 4. Assigning the configuration of monosaccharides, it is the lowest asymmetric carbon atom in the compound. As the plus glucose OH group is on the lowest asymmetric carbon, is on the right side, which is comparable to plus glyceraldehyde. That's why it is your D plus glucose. Look at that. Here we take CHO, OH, H, CH2OH. This is your plus glyceraldehyde, D plus glyceraldehyde. Now let us draw the structure of open structure of D, that is a glucose. This is your CHO, 1, 2, 3, 4, 5. Here is your OH, H, this is the third carbon. It is your OH to the left hand side, H to the right hand side, then OH, H, OH, H, and CH2OH. Look at the last asymmetric carbon of glucose. This is your asymmetric carbon, and compare it with the asymmetric carbon of glyceraldehyde. The OH group is on the right hand side. In glyceraldehyde plus glyceraldehyde, the OH group is on the right hand side of the asymmetric carbon. You know the meaning of asymmetric carbon, that is a carbon whose all the 4 valencies are fulfilled by different group or atom. So that's why it is your D plus glucose. D plus glucose. I hope it is clear to you that let me revise it once more. Glucose is correlated, correctly named as D plus glucose, where D represents the configuration and plus represents dextrorotatory nature of the molecule. The letters D and L before the name of any compound indicate the relative configuration of a particular isomer of glyceraldehyde, and glyceraldehyde contains one asymmetric carbon atom and exists in 2 enantiomeric forms, which already it has been shown, and one form is your right now written on the board. This is your going to clockwise rotation, so D plus glyceraldehyde. All those compounds which can be chemically correlated to plus isomer of glyceraldehyde are said to have D configuration, whereas those which can be correlated to minus isomer of glyceraldehyde are said to have L configuration. For assigning the configuration of monosaccharides, it is the lowest asymmetric carbon atom is compared as in plus glucose OH group, as in plus glucose OH group is to the right hand side of the asymmetric carbon atom, which is similar to the configuration of plus glyceraldehyde. Your asymmetric carbon and OH group is on the right hand side. That's why this structure of glucose has the name D plus glucose, where D is your configuration correlated to the configuration D plus glyceraldehyde, and plus is your what we have discussed represents dextrorotatory nature of the molecule. In the next class, we will go for cyclic structure of glucose. Thank you.